Hello guys, good to see you back. Once again, I'm back with a new project related Python OpenCV. And today in this project, we are going to extract head tilt angle. As you can see, it start my webcam. And now you can see green dots in both of my outer corner. You can clearly see both of them. And if I tilt my head right side, now you can see it print tilt angle in minus value. And at the same way, if I tilt my head at left side, now you can see it print positive value, positive degrees. So this is how we can extract head tilt angle using OpenCV and MediaPipe module. Before we start our coding, let me introduce you something. This project is part of my Mastering Python OpenCV course on Udemy, and as you can see, it is the new, fresh and bestseller course on Udemy. Till today, it come with 11.5 hour plus content on it. And it come with multiple real-world projects. So if you are interested to learn Python OpenCV from the very beginning, I will provide the link in my description. Just check this course on Udemy and you will understand why it has become bestseller. So let's back to the code. Here we extract head tilt angle using our eye corners, eye corner points. And today we are going to create this project with the help of MediaPipe module. So let's jump into the Visual Studio Code editor. So finally, I am in my Visual Studio Code editor. At first, we need to import the module. That module we need to detect our face, which is MediaPipe. So let's open Windows PowerShell. So as you can see here, we open Windows PowerShell, and here we need to install a module, and our module name is MediaPipe. So just you need to type pip install OpenCV Python MediaPipe, and you need to hit enter after that. After hit enter, as you can see, it print requirement already satisfied because I already download this module in my local system, but you need to complete the download process if you don't download it. After install the module, let's back to the Visual Studio Code. Then we need to import the modules. First, I'm going to import CV2 module. So I'm going to type import, our module name is CV2. And next, I'm going to import MediaPipe module. Import MediaPipe as MP. Then I'm going to import another module, and our module name is Math. We need this module to calculate the head tilt position. So I'm going to type import, and our module name is Math. That's it. Then after import the modules, we need to initialize the MediaPipe face mesh. We already learned about it in our previous tutorials. Using MediaPipe face mesh, we are going to detect facial landmarks. As I told you, our face divided into 468 landmark points provided by MediaPipe. And using these landmarks, it creates a face mesh. Let me show you the example. This is the example of MediaPipe face mesh image. These are all landmarks, and all of this landmark connected with straight line. That's why it creates a mesh shape. These are all triangles. Now, to extract the head tilt position from this mesh, we need to work on only two landmarks. Landmark number 33, this landmark, and landmark number 263, this landmark. I want to say we need to extract eye corner points. And using eye corner points, if we rotate my head, we can easily calculate the angle between the eyes and determine the head tilt angle. And remember, right eye outer corner landmark number is 33 and left eye outer corner landmark number is 263. So now let's back to the Visual Studio Code again. And now we need to initialize the MediaPipe landmark. At first, I'm going to declare a variable called MP. MP stands for MediaPipe underscore face mesh underscore mesh equal to, here I'm going to initialize with MediaPipe solution. Some type MP dot solution solutions dot face mesh face underscore mesh. Basically, here we access the face mesh solution from MediaPipe and assign it to MP_face mesh variable. Next, we need to create a face mesh object that will detect facial landmark in video. For that, I am going to declare another variable, and our variable name is face mesh. Face underscore mesh. Face mesh equal to, here I'm going to type mp MediaPipe underscore face mesh variable dot, here I'm going to call a method face mesh. Then inside the round braces, we need to pass some parameters such as static image mode. So I'm going to type static underscore image underscore mode. Static image mode equal to, I'm going to define it false. Now the question is, why we define static image mode false? Because we are going to working on video, not a static single image. That's why we use false here. If we work on static image such as single frame image, then we need to make it true. Then we need to define how many faces we are going to detect. So maximum max maximum underscore number num underscore faces equal to, I'm going to make it 1, because at the same time I'm going to detect only one face. And here I'm going to turn on word wrap to see the code clearly. After that, we need to load MediaPipe drawing utils. For that, again I'm going to declare another variable, and our variable name is mp underscore drawing. mp underscore drawing equal to mp MediaPipe dot solution. MediaPipe dot solution dot, here I'm going to access drawing utils underscore utils. We are not going to use it in this example, but it is commonly used for drawing landmarks. We are not going to build any face mesh in this project. Now after that, we need to create a function that can calculate the angle between these 2 points, this eye corner point and this eye corner points. So let's jump into the code editor again. So here I'm going to define a function called calculate angle, the angle between 2 eye points. So I'm to type def calculate underscore angle, calculate angle, and this function take only 2 parameter, p1 point and p2 point. This function take total 2 argument, p1 and p2. p1 is our first point which represent right eye, and p2 is our second point which represent left eye, and every point hold total 2 value x and y axis. And next we need to calculate the vertical distance between 2 points, and to store the vertical distance value I'm going to define another variable, and our variable name is delta underscore y. This is delta y value. Delta y equal to p2. From this p2 I want to access the first point 1 and minus p1. From p1 I want to access the second index, so I'm going to pass 1. This is y coordinate of second point and this is y coordinate of first point. And if we minus first point y coordinate with second point y coordinate, it will provide us vertical distance. And at the same way we need to calculate horizontal distance between 2 points. So I'm going to duplicate this line and I'm going to make it delta x value. Delta x equal to p2 point, and from here I want to access the 0 index from p2. Also I want to access the 0 index from p1. And if we minus these 2 points, then it's going to provide horizontal distance between 2 points. And now we have the horizontal distance, also the vertical distance. If I tilt my head, we can easily calculate the angle between these 2 points, because now we have horizontal and vertical distance. And to return the angle value, I'm going to type return, and here I'm going to use a method called degrees, math.degree method. From math, I want to access degrees method, degrees. Then inside the round braces, here I'm going to use another method, and I'm going to type math dot ATAN2. Then inside the round braces, we need to pass total two argument. Delta, here I need to pass delta y value, and after comma, we need to pass delta x value. And I'm going to save this file. It's math, not math.atan2. Basically, this method math.atan2 calculate angle in radians. And this method math.degrees convert radian to degree values. At first we convert angle to radian value, then we convert it radian to degree value. Now after create the function, and then I want to start my webcam. So I'm going to declare another variable cap equal to, and here I want to open my default webcam. So I'm going to type cv2.video capture method. Then inside the round braces, I'm going to pass the default webcam number 0, and I'm going to set this file. And as you know, if we capture any frame, also we need to release it. So I'm going to type cap dot release method, release. Also we need to destroy all the windows that we create. So I'm going to type cv2 dot destroy all windows. Then here I'm going to create a while loop. Here we need to start a loop that continue as long as the webcam is open. So I'm going to type while cap dot is open method is opened. Then inside this while loop, I'm going to read the camera frame using cap.read method. And as you know, cap.read method return total two value, a boolean value and the frame. So to store the boolean value, here I'm going to declare another variable called success, and to store the image, I'm going to declare another value frame equal to, here I'm going to assign cap, I'm going to call, and here I'm going to call cap.read method, cap.read. Then I'm going to set a if condition. If not success, then inside this if condition, I want to print a statement, print, here I'm going to type inside the double quotes, I'm going to type ignoring empty camera frame, ignoring empty camera frame. Then I'm going to print continue. At first, here we start a loop that continue as long as the webcam is opened. Then we read one frame from this webcam. If it reads successfully, then it's going to store a value. It's going to store a boolean value. If it is success, then it's going to store it 1. Otherwise true. Next we handle an error. If frame reading false, it skip the rest of the loop and try again. So this is it for this tutorial. At the next part of this tutorial, we are going to work on the frames. So thanks for watching this video. Stay tuned for our next tutorial. Hello guys, nice to see you back. This is the second part of this tutorial. Now at first, inside this while loop, we need to get the height and the width of this frame. For that, I'm going to declare total two variables, h for height and w for width. And also, I'm going to declare another variable underscore equal to frame.shape. Frame.shape. The first variable represent height, and the second variable represent width, and the third variable underscore represent color channels. Next, we need to convert the BGR frame into RGB frame. As you know, by default, OpenCV read our frame in BGR mode. So here I'm going to declare another variable frame underscore RGB. Frame underscore RGB equal to cv2 dot cvt color inside the round braces At first, I'm going to provide the frame, in which frame I want to change the color. After that, we need to provide the color port. So I'm going to type cv2 dot color bgr2 RGB, this one, and I'm going to set this file. Next, we need to process RGB frame through the face mesh module and get facial landmarks. For that, I'm going to declare another variable results. Results equal to face underscore mesh, face mesh dot process method, process. Then inside the round braces, we need to pass the frame RGB frame RGB, this one, and I'm going to save this file. So after process the frame, here I'm going to set a if condition. If results dot multi-face landmark face underscore landmarks, then inside this if condition I want to use a for loop. For face landmark face underscore landmark in results dot multi-face landmarks face landmarks, then inside this for loop. But before I jump into the for loop, let me explain what is this if condition and why we use this for loop. First of all, here we check if any face were detected. After that, then inside this if condition, here we loop through face landmark in detected face. Basically, using this for loop, we access all the landmark in our face. Then we need to get outer corner of both eyes. For that, I'm going to declare another variable, and our variable name is right eye outer. Right underscore eye underscore outer equal to, and here I want to access landmark number 33. So I'm going to type face landmarks dot, and from here I want to access landmark. Inside the square braces, I want to access 33 number landmark. After that, at the same way, I want to access left eye outer corner. So instead of using right, I'm going to type left. Left eye outer corner landmark number. This one is landmark number, and here I'm going to pass, I want to access 263. This one. This is for left eye outer corner landmark. Remember, each landmark is a point. It holds x-axis for horizontal position, y-axis for vertical position, and z-axis for depth position. And next, we need to convert these normalized coordinates into pixel value. For that, I'm going to do it for, first I'm going to do it for right eye. So I'm going to define a variable right underscore eye. Right eye equal to, then inside the round braces, first I'm going to use int method because we need to value in integer format. So I'm going to type int. Then inside the round braces, here I'm going to type right eye outer. I want to, and here I want to access the x-axis direction x, and I want to multiply with w, width of this frame. This is right eye x-axis position. So after comma, at the same way we need to extract. I'm going to use int method int. Inside the round braces, this time we need to access the right eye y-axis coordinate. So I'm going to type right eye outer dot y, and here I'm going to multiply with edge height, and I'm going to save this file. Then I duplicate this line, and we need to extract left eye. So here I define another variable left eye, and this time I want to access, instead of right eye, here I want to access left eye outer x-axis and left eye outer y-axis. Now the question is, what we basically do here? Remember, right eye outer x and right eye outer y is a normalized value between 0 to 1. Then we convert this normalized value into pixel value. Basically, here we multiply right outer x value with height, and w and h represent width and height of this image frame. So if I multiply with x-axis, it's going to return us pixel value of x-axis position of this right eye, At the same way, if we want to extract the y-axis, if we multiply y-axis with height, if we multiply this value with height, then it's going to return the pixel value of right eye. Basically, it returns their position in pixel. So we have the position. Now I want to draw eye corner points. For that, we are going to use circles. So I'm going to type cv2.circle method, circle. Then inside the round braces, I want to draw circle in this frame. So I'm going to pass this variable, and at first I want to draw in right eye. So I'm going to type right eye. Then we need to define the center point. And right eye is the center point where we want to draw the circle. After that, we need to define the radius, and for radius I'm going to use 5 pixel radius. Then we need to define the color of this circle, and here I want to use 0, 255, Z. It's a green color. After that, the comma, I want to fill this circle with color. So I'm going to pass this code -1, and I'm going to save this file. Then I duplicate this line, and I'm going to do the same thing for left eye. So instead of using right eye, I'm going to pass left eye variable, left eye, and I'm going to save this file again. Next, we are going to calculate the angles. To calculate this angle, we are going to use this function, and our function name is calculate angle. So I'm going to call this function. We already created this function in our previous tutorial. So here I'm going to define a variable angle equal to calculate angle. I call this function. Then inside the round braces, I'm going to pass, at first I'm going to pass right eye variable, right eye. Then I want to pass left eye variable, left eye. As you know, this function going to return the angle value. So we have the tilt angle of our head. After that, we need to print this tilt angle value in this window, in this current frame window. For that, we are going to use put text method. So I'm going to type cv2.putText, put text. Then inside the round braces, at first we need to pass the image source, which is frame. Then we need to pass the angle value. But before, I'm going to use fstring. So inside the double quotes, first I'm going to type head tilt angle, head tilt angle, colon. Then inside the curly braces, I'm going to pass the angle variable, angle, this value. I want to print angle value here. Then I'm going to type semicolon dot to f. Now what does that mean? The text we want to draw here is a variable, like a float, and here colon dot to f means I want to show it with 2 decimal places. Example, head tilt angle 15.67 degrees. So after that, inside the double quotes also we need to pass the unit degrees. Then after comma, we need to define the position, the origin position of the text. So inside the round braces, I'm going to pass 30 from the x-axis and 40 from the y-axis. This is the starting point of this text. Then after comma, we need to define the font face, in which font style we want to use. So I'm going to type cv2.fonthase simplex, this one. Then we need to provide the font scale, and here I'm going to use 0.8. After that, we need to define the font color. So inside the round braces, I want to use blue color. So I'm type 255, 0, 0. Then we need to define the thickness of this font, and I'm going to pass 2 here. After that, I'm going to save this file. So after put the text, we need to go outside the if condition. So outside the if condition and for loop, we need to display the frame. So for that, I'm going to use cv2.IamShow method, IamShow. Then inside the round braces, first we need to provide a display name, which is real time head tilt detection. And then we need to provide which frame I want to display. and our frame name is frame, and I'm going to save this file. After that, we need to set a if condition. If cv2 dot wait key, and I'm going to wait for 1 millisecond and 0 x ff equal to ord, then inside the round braces, if I press small q, then inside this if condition I want to break the loop, then I want to break the while loop, and I'm going to save this file. Now after save this file, let's run the code in our terminal. So I'm going to hit the run button. After I hit the run button, we need to wait for some time to start our webcam. So let's wait for some time. As you can see, it start my webcam, and now you can see green dots in both of my outer corner. You can clearly see both of them. And if I tilt my head right side, now you can see it print tilt angle in minus value. And at the same way, if I tilt my head at left side, now you can see it print positive value, positive degrees. So this is how we can extract head tilt angle using OpenCV and MediaPipe module. And if you want to close this window, just you need to press Q on your keyboard. So this is it for this tutorial. I hope now it's clear for you how we can create it. So thanks for watching this video. Stay tuned for our next project.